Hi, everyone. So with that ends our HTML, CSS first lecture and workshop. So now we're going to dive into JavaScript. So just a recap from this morning, HTML describes the content and structure of our websites and what exists and how it's organized. CSS describes the presentation of our website, and that can include colors, fonts, the alignment, border shading, and more. So what is JavaScript? JavaScript is a programming language that manipulates the content of our web page, and it's how we take the HTML and CSS that we wrote this morning and we actually make it interactive. So that's adding buttons, navigating to maybe other web pages within our websites. And it's used by a vast majority of websites and web applications today. And JavaScript is not related to Java. So these things are completely separate. So where does JavaScript go? And where can we run JavaScript code? So one way we can run it is actually in the browser console. On Windows, we can actually open up our browser console in Chrome and Firefox with Control-Shift-J. It's also on the whiteboard. And on Mac, it's Command-Option-J on Chrome and Command-Shift-J in Firefox. And you can also right-click, inspect, and go to the console tab that opens up whenever you do that. So that would kind of look something like right-click and inspect the element here. And then after you get up your tool, so this would be Safari, but there's a console here, and you can write JavaScript in the console here, and it would be similar on Chrome. So JavaScript really is tied to our HTML files, and we'll have more on that in a bit. So what is JavaScript and how do we do it? So JavaScript has 5 primitive data types. Boolean, which is true and false. We have numbers 12, decimal, 1.68, negative numbers as well, and also 0. We have strings like the string hello, world, 12, and we can also have the empty string here. And we also have 2 other types, which are null and undefined. We'll get more into some of those other ones later, or some of those in more detail later. So with operators, they kind of mostly work how we expect. So we have 2 types of operators. The first are arithmetic operators, which would be like addition, subtraction, multiplication, division. And they work as how we expect. We can also add strings. We also have comparison operators. So we have equals, not equals, less than, greater than, and less than or equal to. We also have greater than or equal to. And note the triple equal sign. So in JavaScript, why don't we use double equals? So we use triple equals to check quality in JavaScript. And if we take a look at some of these examples, if we say 2 with triple equals 2, we get true. But if we say 2 triple equals the string of 2, we get false. And if we do that with the double equals, we get true for both. And the reason why this is because if we use double equals, it performs type coercion, which it forces the arguments on the left and the right to be the same type before we actually compare them. So if we use double equals and did an integer and a string, we would get true. So the TLDR of this is just don't use double equals and always use triple equals, or use exclamation point and 2 equal signs for not equals. So what is the syntax of JavaScript? So here on the left, we have some code, which is the greatest common divisor of 2 numbers. And so we can notice that every statement in JavaScript generally ends with a semicolon. Note that this is optional, and if you don't include them, it is the code will still run. However, generally it's good. It's better for readability to have semicolons. Next, white space is ignored, but it can improve readability. So right now we have white space here, for example, and we don't have any white space within our function. But if we added more white space, it would still run the same, and it might improve readability. For our function here, so this is a function. Abby will talk more about that later. But we have curly braces at the beginning and at the end here, which they denote where blocks end and begin. So all of the code within this opening bracket here and this closed bracket is called a block. And this also applies here to our while loop. So we have an opening brace and a closing brace to denote this as a block. And using double slash, we get comments. This doesn't affect how the code runs, but you generally should use them to keep code readable. So next, maybe how can we define variables? So one way we can do this is by using the let keyword, and then the variable name, and then whatever we want to set the variable equal to. So we can give this variable, my boolean, some value true. And generally in JavaScript, the convention is to use camel case. So the first word is lowercase, and then every other word after that will be capital. Note that this is just convention, and it doesn't affect how any of the code actually runs. Another way we can define variables is by using the word const, and this is to define constants. However, if we use the const keyword, we actually cannot reassign this variable later. So if we use const here and we say the answer to life is 6.148, and we try to redefine it to be 42 later, we're not actually able to do that. So maybe one question that you have now is, why would we ever use const if we have let? And generally, this is just for safe code practices. So if something should never be changed, generally we don't want to let it change. So in this example, if we have 60 seconds per minute, we define it as 60. We don't ever really want this to change, so we should use const instead of let. Another thing that you can use, and you might see online, is the keyword var. The TLDR of this is just don't use var. So the technical details of this, if you really want to get into it, you can Google it. But let is block scoped, so we talked about block earlier. You can only see those things within the block that you're in. Var is function scoped. And the reason why let now exists is because the people kept getting bugs when trying to use var. With that, does anyone have any questions about anything we've covered so far? Okay, going on. So earlier I mentioned that there were two other types, null and undefined. So to get into those a little bit more, undefined means that we have declared a variable, we haven't yet assigned it a value. And null means we have no value. So in this case here, we said let is equal, or we're defining some variable, first name. And since we haven't actually used the equal sign and put something here, first name actually is undefined. So it doesn't have a value yet, but we have a variable for it. Now maybe we could set that first name equal to Albert now that we have a name for it. And we could also, maybe later we wanted to change the first name to be null. So we can essentially give our first name variable no value. So it's a little bit different than undefined, because undefined just means it doesn't have a value, whereas null means there is no value. Next, we have console.log for outputs. So it's essentially like print in Python. Console.log allows us to write to the JavaScript console. So in this case, we have console.log, and we have something that we want to actually print out. And whenever we actually run this input, we actually get the output of what was inside of the console.log. Another way we could, console.log is generally very useful for debugging. So in this case, we let the salary be equal to 30,000. We add 5,000 to that salary, and then we multiply it by 2. And if we print out the salary, we should get 70,000. And so for debugging, we can maybe use console.log here and print the salary to see if we actually get 70,000. Another way we can actually debug with console.log is something called template strings. And we usually could use these for more descriptive logging. So we could use this, the tick here, with anything that we write inside of that will be like a string. And we can use the money sign or the dollar sign with curly braces to denote JavaScript expressions. So if we define a constant a to be 5, a constant b to be 10, and we want to see what this product is, we can maybe say, okay, we want to print out a times b is equal to what? And then we run our JavaScript expression here, and it will actually multiply a times b, and we get 50. So this is just another way to actually print out. So maybe you can, if you have a lot of prints or logging going on, you can kind of see what is being logged where. Another thing that we have is alert. So alert generates a pop-up notification with the given content. So in the case here, we have the function alert, and we pass in the string congratulations. And whenever this actually gets executed on our browser, we get some little pop-up notification that says congratulations. Do we have any questions here? Okay, moving on. Next, we have arrays. So arrays can generally be used for whenever we want to store a sequence of items, generally we want these to be like similar. So maybe we initialize some array pets with elements flower, 42, false, and bird. And we can denote an array with brackets. We can access elements in our array by using the name of the array with brackets and the element that we want. Note that JavaScript is zero index, so the first element here is 0, and then 1, 2, and 3. So whenever we try to get the third element of pets, we actually get bird. Another thing we can do with arrays is replace elements of arrays. So if we have pets and we want to replace the second element of pets, which is currently false, and we redefine it as hamster, our array will now be flower, 42, hamster, and then bird. We have another example here. We have pets with cat, dog, guinea pig, and bird. And we have two methods on arrays. So one method here is pop, which allows you to remove elements from the end of an array, which is the same in Python as well. So if we pop from pets, we remove bird. So this will be our new array. And we have push, which is similar to append in Python, which would allow you to add rabbit to the end of the array. So pets.push with rabbit adds rabbit to the end of the array. Next, we have conditionals. So we often want to perform different actions depending on what conditions we have. So for this, we use conditional operators. We have if, else, and else if. So else if is analogous to elif in Python. So we could do this in JavaScript by using if, and then with parentheses our condition, and then curly braces denote whatever you want to run whenever you're inside of that condition. So in this case, if the hour is less than 12, we want to log good morning. If that's not true, then we look at our else if. If it's less than 16, good afternoon. If it's less than 20, good evening. And otherwise, we log good night. Indents here are not necessary, but they keep the code a little bit cleaner and more organized. So you don't have to have any of this white space here, but it just is for formatting. Next, we have while loops. So maybe what if we want to repeat an action as long as some condition is satisfied? So let's define some variable z equals 1, and maybe while z is less than 1,000, we want to multiply z by 2. So if we did this until z is greater than or equal to 1,000, we would actually get 2, 4, all the way up to 1,024. And note here that whenever z is 512, we actually are going to print out z times 2, so we'd still actually print out 1,024. And whenever it goes back to our while loop next time, it will be 1,024, and so it will exit out of the while loop. And so just be wary of the syntax here. So we have curly braces for parentheses for our condition, and then curly braces to denote the code that you will run whenever this condition is met. So now we have another example, which is the same array as before. For loops are generally more useful whenever we want to iterate through indices. So if we have a for loop here and we want to iterate over our pets array, we can say, okay, while we define I to be equal to 0. So note that we have this let here because we're creating some variable. So we actually have to define it using let. And we want to do this while I is until I is not less than the length of pets. And we want to increment I with every iteration, so we denote this with double plus. And so every iteration of this for loop, we print out the phrase, I love my blank. And so whenever I is 0, we print out cat. We then print dog, I love my guinea pig, and I love my bird. And one thing here is that maybe it looks like we're redefining this constant every time. With the way for loops work in JavaScript is that this variable is local to each iteration of the for loop. So because this is inside of this block here, whenever we go back around again, it clears that. So we can actually use a const here. Maybe we want to iterate directly over the pets array, so this is a more Pythonic way of iterating. So in Python, we use the keyword in. In JavaScript, we actually use the keyword of. So we have a const animal of pets, and this essentially behaves the same way, but instead of iterating over the indices of pets, we just iterate over the animals. So we still get the print, it still logs out, I love my cat, I love my dog, I love my guinea pig, and I love my bird. Any other questions, comments, or concerns with what we've covered so far? Yes. Yes, so you can have like other arrays inside of arrays. Yes.
What do you mean by change arrays?
Yeah, so arrays are immutable. Or they are mutable, so you can change them by push, like adding things, changing the indices, popping from the end of the array, pushing to the end as well. Yeah. Any other questions before I pass it over to Abby to finish intro JavaScript? Okay, so with that, I'm going to hand it over to Abby to talk about. Oh wait, this is my stuff.
Oh,
sorry.
Oops.
That's okay.
Okay.
Sorry. So maybe we want to represent this car here, but we don't have a primitive data type for this so far. So we have something in JavaScript called objects. An object in JavaScript is a collection of name-value pairs. And so here in this example, we maybe have our car, and we have our car that has a make of Ford, a model which is a Mustang, a year which is built in 2005, and the color is red. So that represents the car that we had in the on the last slide. And of our object, there's two ways of accessing properties. So one way we can do this is if we know the property name. So our car has a model, and so we can access the model of the car with this dot notation here. So our object myCar.model will give us the model of the car, which is Mustang. And same here with the color of the car. We can also use the brackets to access the property. So we can say my car and then color here, and it will give us red. Another way we can do this is with something called object destructuring, which is a shorthand to obtain multiple properties at once. So this is kind of what we had. It's very similar to what we had on the last slides. We have myCar.make and myCar.model to actually get the make and model from the car. And this is without object destructuring. But with object destructuring, we can do this on one line here. So we can define the make of the car to be the property of the myCar object that's make. So it corresponds to the name of the property of the object, and same with the model. So this is the same way of doing. This is two different ways to do the same thing. Generally, you can use what's on the right here to save space and make cleaner code. And so earlier we mentioned equal signs and not equals. So here's a little bit about equality. We use triple equals to check if two primitive variables are equal in JavaScript. And note here that we're just saying primitive. And if this kind of expects works how we expect. If we say 2 does 2 equal 2, we get true. 2 doesn't equal 3. The string of 2 equals the string of 2, but the integer 2 does not equal the string of 2. And what is triple? Maybe one thing we're wondering is what does triple equals mean for arrays and objects? So if we have an array here 1, 2, 3, and a second array 1, 2, 3, and we try to do triple equals between these two arrays, we actually get false. Same for objects. So if we create some object person 1 with the property name, which is Bill Gates, same for person 2, and we try to check if these two things are equal, we actually get false. And why is that? Using objects and arrays, these define references, and they actually point to where the data is stored. So in the last example with Bill Gates, this actually checks if these two references for person 1 and person 2 are equal. So this kind of looks something like this here on the right. We have person 1, which is this object here, which has name Bill Gates, and same with person 2. But note that these objects are like two separate objects. So this first object is stored one place in memory, and this second object is stored another place in memory. So whenever we actually use triple equals between these two objects, they're not in the same place in memory, so we get false, even though their properties are all the same. And the same also goes for arrays. So one thing that you might be wondering is, if we have these two objects, how can we actually check if they're equal? And we have to actually go through manually and check. So if we have the arrays from the last slide, 1, 2, 3, we actually have to iterate over the array to see if each index is the same. So next, how to copy arrays and objects. It's not as simple as something like this here. If we set array is equal to 1, 2, 3, and we say copy array is equal to array, this doesn't work. Why not? This is because whenever we say copy array is equal to array, we're using this copy array to point to this exact variable. So it just makes a reference to the same location in memory. So in JavaScript, really quickly, if we had something like this, if we have our array 1, 2, 3, and we set this equal to the array from last time, and we actually edit the 0 index of the array, and we log out the array and the copied array, we will oh, sorry, I'm in the wrong folder. We notice that these two arrays actually have the same thing because they're pointing to the same place in memory. And if we maybe add a second example, we want to change the first index, it would still change as well. So how can we actually copy arrays and objects? One way is to use the spread operator, which is denoted with 3 dots or an ellipses. So if we have some array and we want to copy the array into copy array, we can use our array here with 1, 2, 3 dots and then the array. And we can do the same thing with the objects. You could actually just manually copy it over, but where's the fun in that? Any other questions? Yes? Sorry? Could you repeat your question? Sorry.
Not really. Yeah, JavaScript is similar to Python where it's more high level than something like C where you use pointers, so you don't really use them in JavaScript. I don't even know if they exist.
Okay, so with that, I'm going to pass it over to Abby to talk about functions.
Thank you. Okay, a couple notes. Oh, I'll just use this. A couple notes before I move on. This is assuming that we're kind of assuming that you all have programmed in some language before, so you've seen all these concepts before. If you haven't, and as we were blazing through the slides, you're like, what's going on? Do not worry. Just come to office hours tonight if you can, or reach out to us if you can't make it to office hours, and we will make sure that you get all caught up on all of this stuff. Also, looking at time, we might go like 5 minutes over, but if you have to leave to go somewhere, feel free to. All right, so the last topic for today is functions. And so you've all seen this before. We take in an input from whoever's calling the function, and then we take that input and we do something with it. That do something could be calculating a value based on the input that we want to return, or it could just, we could not really care about what we return and just care about what goes on in there. So the way we define functions in JavaScript is like this. And this syntax is entirely analogous to the diagram that I just drew up here. We have the inputs, which will go inside parentheses, and then this cute little arrow thingy, and then inside curly braces, we denote what we want to do with those inputs. So this is an example of a function that converts a temperature in Celsius to Fahrenheit, and this is how we represent a function in JavaScript, with the inputs, the arrow, and the blocks. So what this code that I currently have up on the screen is doing is it's going to take some space in memory, as represented by that little gray thing there, and it's going to store this function somewhere in memory. So it's going to go, hey, okay, I want to hold on to this idea that I have the ability to take something in Celsius and then convert it to Fahrenheit. However, in order to actually call this function and actually use it, we're missing something. What do we need to add so that we can call this function? Does anyone have an idea? Yes. Exactly. We need a name for it. So we need something that will point to this function. And the way that we define a name, add a name to our functions like this in JavaScript, is literally with a variable. So we have this variable Celsius to Fahrenheit, and we're making it point to the location in memory where we stored this function. You'll notice if you look at the syntax that the syntax is entirely equivalent to any other variable definition that we've done. So we do const because we don't want this to change. We don't want to change what this variable name is pointing to. So we declare it with const, and we say the name equals the value that we want to set the variable equal to, which in this case is just the function, and then our semicolon. So the bottom line of this slide is that functions are just values that we store in memory, just like strings, integers, whatever, and so we can have variables that point to them. All right, and then now that we have a name, we can call this function, and so if we want to convert 26 in Celsius to Fahrenheit, then we just call it like this. And the important thing, the reason why I emphasize that functions are just values that we can store in variables is because we can pass them around just like we do with any other values. So another thing that we can do with values or with variables is we can give them as parameters to functions. So that means that we can give a function as a parameter to another function. And tomorrow we're going to talk a lot about this concept and dive into it, get familiar with it, and see a lot of scenarios in which we're going to be using these. But for now, I'm just going to introduce them briefly. Okay, so for a quick practice, everyone open up your console. I have the stuff on the slide there. And write a function that just prints, logs a simple message. And remember to give your function a name. I will give you, maybe 1 minute to do that. Yes. Okay, thumbs up if you're done. Okay, I'll give a little bit more time. All right, for the sake of time, I'm going to move on. But no worries if you have not completed it. You can always play around with stuff in your console later. This is the function that you could have written. So we just have the variable name and then the parameters, which are no parameters because we don't need to input anything, and then we print. So for an example of a callback function, we have this function in the JavaScript library, so the JavaScript authors wrote it for us, that calls a function after a certain delay. So one parameter to this set timeout function is the function that you want to call, and then the second parameter is the delay, how long you want to wait before you call it. So let's say that we want to call our function print something after 5 seconds. My question is how we would do that. So take 10